You ever see a giant steel I-beam holding up a bridge or a perfectly straight railway track and just wonder how? How do we get these incredible, precise shapes from just a raw chunk of metal? Well, let's get into it, because today we're breaking down the amazing process that turns simple blocks of metal into the very backbone of our modern world.
Just take a look at all this stuff. We're talking wires, bars, rails, huge structural beams. They're all complex, they're super strong, and they're engineered to perfection. But it's kind of wild to think that every single one of them started its life as a simple, rough block of metal, what's often called an ingot.
So the big question is, how do you get from a lump of steel to, say, a 1,000-foot-long railway track, especially without just melting it all down and pouring it into a massive mold? Well, the answer is all about pure, immense, and incredibly clever force.
Okay, let's start with the fundamental challenge here. We have our raw metal, right? And we need to reshape it. This whole family of techniques has a name: metal forming.
Now, the key phrase here is plastic deformation. I know, it sounds super technical, but all it really means is we're physically squeezing and reshaping the solid metal until it permanently takes on a new form. We're not melting it. And here's why that's so important. This process actually changes the internal structure of the metal, making the final product way stronger and more durable than if you just cast it into shape. It's brute force, yeah, that applied with some serious precision.
Of course, you can't just squish any old piece of metal and hope for the best. Engineers have to be experts in how different materials behave. Some stuff, like cast iron, is brittle. It'll just shatter under that much pressure. But others, like steel, are ductile, and you can shape them beautifully. And the real game changer? Temperature. A glowing, hot piece of metal is so much more pliable and easier to work with.
Out of all the different ways to form metal, there's one process that is absolute king when it comes to making the long, continuous shapes that literally build our world. It's called rolling. So the principle behind it is actually pretty simple. You take your metal ingot, you heat it up until it's glowing hot and soft, and then you pass it between two gigantic, powerful cylinders, or rollers, that are spinning toward each other. The gap between them is just a little smaller than the metal, so it gets squeezed.
And this is the perfect way to think about it. It is literally a giant, superpowered rolling pin for metal. The rollers grab the steel, pull it through, and compress it. The only difference is this rolling pin can weigh hundreds of tons and is squishing a block of glowing hot steel.
So what actually happens to the metal as it goes through? Well, three things. First, obviously, it gets thinner. Second, and this is the most dramatic part, it gets way longer. I mean, that metal has to go somewhere, so it just shoots out the other side. And third, it only gets a tiny bit wider. The physics of it just means almost all of that squishing turns into length.
But this isn't just about random squeezing, not at all. It's a highly controlled engineering recipe, and like any good recipe, it has some really key ingredients you have to get just right.
Engineers basically have these four main knobs they can turn to control the whole process. There's the temperature of the metal, which we talked about. Then there's the diameter of the rollers themselves. Fun fact, smaller rollers actually make the metal stretch out more. Then you have how much you reduce the thickness with each pass, and finally, the speed of the rollers. Every single one is carefully adjusted to get the exact final product they need.
All right, so the machines that do all this work are called rolling mills, and they come in a few different setups, each one a really clever solution to a specific engineering problem.
Let's start with the most basic one, the duo mill. It's exactly what it sounds like, just two rollers. To make the metal thinner and thinner, you could just pass it back to the start, or, even smarter, you just reverse the rollers and send it right back through. Simple, effective. But what if you want to go faster? Reversing those giant motors takes time. Well, you enter the trio mill. To speed things up, a third roller is added right in the middle. The metal goes through the top two, and then it's immediately fed back through the bottom two in the other direction. No more stopping and reversing the motors. It's all about efficiency.
Now this is where the engineering gets really, really smart. This is a quarto mill. See, the incredible pressure needed to roll steel can actually cause the main rollers, the ones touching the metal, to bend just a tiny bit in the middle. So what's the solution? You add two much larger backup rollers to support them, which keeps everything perfectly straight and ensures a totally uniform thickness.
Okay, so we've got our process, we've got our machines. Let's connect the dots and see how this all comes together to create the final products that we use every single day.
So the journey begins with a semi-finished product that's already been cast. These usually come in two main families:
a wide flat piece called a slab or a brame, or a more square-like piece called a billet or biellet. And the starting shape you choose is absolutely crucial, because it dictates what you can make in the end.
And you can see the difference really clearly here. On the left, that's a slab. Think of it like a giant metal plank. On the right, those are the billets, which are basically thick, square bars. These two shapes are pretty much the starting point for everything that gets rolled.
So, if you start with one of those big flat slabs, you do what's called flat rolling. You're basically just making it thinner and thinner and thinner. This is how you get those heavy plates for building ships, thin sheets for car bodies, or those massive coils of steel.
But if you start with a square billet, that's when you can do something way more complex. This is called shape rolling. And here's the really amazing part. The rollers themselves aren't flat anymore. They have special grooves cut into them. So with each pass, the metal is gradually squeezed into more and more intricate shapes, almost like a puzzle, until it eventually becomes the rails, bars, and I-beams that are the very skeleton of our entire infrastructure.
So, the next time you see a skyscraper reaching for the clouds, or you're traveling on a train, just take a second. The steel that makes all of that possible wasn't just melted and poured into a mold. No, it was squeezed and stretched and shaped on an incredible journey from a simple block into a final perfect form. Just look around you. How many things in your life began their journey between two powerful rollers?